So now we'll switch over to our Features tab. So you can see we already have our plane, our line, and our point that we use for our alignment. Now we'll go through the blueprint, and we can do this a whole bunch of different ways. I'm thinking the easiest way is to just touch all of the features that we need for these balloons in the order that we see the balloons. We may have to go back after the fact and add some more features or modify them because we didn't think it all the way through initially. Whatever, it is what it is. That's why Calypso is so flexible and lets you add more features later. So for starters, what features do we need to output balloon number 1? What do we need to actually touch on the part? Balloon number 1. Yeah, we need to touch this circle and that circle. And looking at this circle, there must be a diameter call out somewhere. There it is right there. It's balloon 5. So that's 472 thousandths. And I noticed that there are 3 of them. It says 3 times. Okay, well, how many points do we need to touch on those features based on the tolerance right here? Minimum of 3 points. I'd probably do 4 just because it's mechanically easier to touch at the 12, 6, 3, and 9 o'clock positions. But 3 would be fine as well. We don't need a huge amount of points because the tolerance on that's plus or minus 5. It's a 3-place decimal. You look down in the title block, 3 places is plus or minus 5. All right, easy enough. So plus or minus 5 there. I notice also we are going to have to do depths at some point. So while I'm in those 3 holes, I might as well touch the depths too. Again, we can always change the order of these after the fact. I'm just trying to figure which features do we need to touch. So yeah, we need to touch 1, 2, 3 circles. We'll do 4 points each. We need to touch the depth at the bottom of those holes, and those are plus or minus 10, so we can just touch 1 point at the bottom. And then we also need to touch this hole here for balloon number 1. And the diameter of that one's plus or minus 2. So how many points are we going to touch when we touch that center circle? 7. Yeah, 7 would be good. 7 or more. Yep. We could do a scan path as well. Plus or minus 2 is pretty tight. Now, this is coming later, but when we do our manual verification, we should also pay attention to the fact that this is a tight tolerance, plus or minus 2. And this is not a tight tolerance, plus or minus 5. So when we're doing our manual verification, it kind of follows the same rules. You can use dial calipers to check that diameter, but you should use something more precise when you check this diameter. So yeah, for starters, let's go touch the diameter of 1, 2, 3 holes. We'll do 4 points apiece. And then we'll touch the depth at the bottom of those 3 holes. And then we'll go touch this center hole here, and we'll do 7 points. Now, we could do this with the teach-in method or the CAD method. I'll show you both of them just so that you're comfortable with both. For the 3 holes, it might be just a little faster to touch with the teach-in method. So I'll come down, or I'm sorry, with the offline method. So I'll come down here and I'll define a circle on a cylinder, and I'll go 1, 2, 3. Now when I do that, there's no strategy applied, right? It has just gray in there. There's no intelligence to that. So I'll double click on it. I'll come into strategy here, and notice that it gives me a circle path. And right now, geez, it's set to 50 points, and it's doing a scan path. I will take points off if you do a scan path, and you're taking 50 points for something that's plus or minus 5. It's way slower than it needs to be. It's not necessary. It's overkill. So if you want to do it with CAD, you just want to come back and set that to either 3 or 4 points, and you want to make sure you check on the box that's single points and say OK. I'll do exactly the same thing for circle 2. I'll come into strategy, circle path. We'll set that to 4 points, single points, and OK. And then we'll do the same thing for circle 3. We'll go strategy, circle path, 4 points, single points, and OK. All right, so far you notice that now this is colored in dark gray, but it's still not green yet. We haven't actually touched those points on the model. So we don't have any information about that until we touch the points. That's because we did that using the CAD method or offline method. For this other hole here, I'm going to touch using the probe itself. I'll go use the teach-in method for that. And that's easy too. Just make sure you're out of any command. Use the joysticks to go over and touch 7 points. The only difficult part about this is getting those 7 points to be evenly distributed. So 1, 2, 3, 4, 5, 6, and 7. I've gotten more phone calls today in the last couple hours than I have in the last multiple months. I don't know what's going on there. So then I say okay there. Now you notice that that comes in as circle 4. Notice also that it's green. That's a benefit of using the teach-in method, is that it has all of the information that it needs already. I already touched those points. I don't need to go touch them again. Okay, we also said we needed to touch the depth at the bottom of these holes. Well, that one's easy enough to do using the teach-in method. I'll touch a point, say okay, and I'll come over and touch another point. Say okay. What's the biggest thing you have to remember here? It's like I'm doing 3 things in a row. They're all the same thing. It's really tempting to go touch all those points and then say okay. What would that do?
Try to create a plane, right?
That would try to create a plane or some other geometric feature, yeah. So just, if you're doing the teach-in method, just remember to hit OK in between. That's my biggest point of advice there. All right, what else do we need to touch? Do we have enough information to output balloon 1? We need 4 points for a circle here, 7 points for a circle there. Got it. All right. Balloon number 2, 1 inch 583. Do we have what we need?
Yes.
Our alignment comes from here. We already know where this circle is, so we can simply output the Y location. Got it. Point number 3, do we have what we, or balloon 3, do we have what we need? Yeah, 7 points for that circle. Beautiful. How about point 4? Or balloon 4. Yeah, we already know where this circle is. We already know where that circle is. Beautiful. Balloon 5. Now keep in mind, balloon 5 is going to be B5.1, B5.2, B5.3. There are 3 separate occurrences for balloons.
Same for 6, right?
What's it?
And same for 6.
Same for 6, yep. There's going to be B6.1, 6.2, and 6.3. And we have what we need for both. We have 4 points on each circle to do the diameter. We have 1 point at the bottom of the depth to do our depth. Now how about balloon 7? Now this one's tricky. We actually need not just 1 feature here, but 2. Does anybody know what they are? Yeah, we need a line. We can do 1, 2 points over here. And then we need a separate line, 1, 2 points over here. Now, when I was doing this final exam review last week, by default, my brain short-circuited, and I thought I only needed a line with 2 points here. And then I went to output the tolerance, and I realized that if you only have 1 line, you're not doing what the dimension says. This dimension is pulled off of this surface specifically, not the original alignment, not the base alignment. So we need to touch 2 lines, and we'll do angle between features. This is something that wasn't shown to you in the videos, but I think you'll like it a lot better than what I showed you in the videos. It's way easier. Yeah, we're not going to have to do any alignment shifting or anything like that. I see someone clapping over there for those of you that can't see in the video. So we'll touch 1, 2 points over here. That gave us a line. You can see, that's so cool how you can pull off the CAD model or off the actual part like seamlessly. It doesn't make a difference. We'll say OK there. And just to show you how to do it using the CAD programming, for the second one, I'll do define a line on a plane. And I'll come over here, and I will create my line right there. Now just keep in mind, when you're doing the CAD programming, it has not actually touched the points on the model. And you will also have to define the strategy. Just double click on it, go into strategy. See that it wants line auto path by default, and single points are off. I do not want you doing scan paths here. We're going to do single points. So you just have to, if you're going to do it with CAD, you do have to turn single points on, set your number of points to 2, and say OK. So that's the one thing you got to watch out for with using CAD. Well, there are 2 things you got to watch out for with using CAD. A, don't put the part on the plate, because the CMM will try to drive into itself. Your manual alignment will take care of that. So that's the first thing. And the second thing is make sure you set your strategies. All right, is everybody with me up till this point? You can just give me a thumbs up if you're good. All right. So we have what we need for balloon number 7. How about balloon 8? Yep, we got the center circle. We have this circle. That's beautiful. How about balloon 9? There, we can come from the alignment, which is right there, and just directly output the x-coordinate of that circle. Beautiful. 10. We do not have what we need for 10. So we can either touch a point or a line on the front of the part. Does it matter which one we do? Not really. A point would probably be fine here. So we'll come over and touch one point on the front of the part. Why would we pick a line versus a point?
Parallel or perpendicular.
Yeah, only if you need to output angles or if you want to increase your precision. Right, so when I say increase your precision, I mean if there was like a divot in the part where we touched that point, that could make the part look bad when it's not really. Whereas if we touch this as a line or a plane, you're just going to take a better average of where that surface is. So technically speaking, it would be more precise to touch an entire plane on this front surface. What's the problem with touching more points for a plane?
More time.
Just more time. That's really the only difference. So you could touch a point, a line, or a plane on the front. I would say, within reason, anything between 1 and 5 points would be reasonable. Anything beyond 5 points are wasting time, because this is a low precision tolerance. All right, so point number 10, or balloon 10, we have it. How about balloon 11? We just touch a point on one side of this slot and then another point on the other side of the slot. Good, I hear a no. That's the correct answer. So that one's kind of tricking. I was trying to trick you there. So we could put just a point on the front of the part to output balloon 10 because we're taking advantage of the Cartesian coordinate system. We're locked into an x, y grid that are perpendicular. However, this angle, or this slot here is on an angle. We don't know what that angle is. So we have to have a line on one side of the slot so that we can shoot off of that line perpendicular. So in this case, we want a line with a minimum of 2 points on one side of the slot, doesn't matter which. And then we could have either a line or a point on the other side. In this case, I'm going to do a line on this front side, and then I'll do a point on the back side.
Would you better have 2 points for the opposite because it's at an angle?
Nope. Anytime you have more points, you're going to get a better representation of what the part is doing. But it's only going to take the angle of the line from the second feature you pick anyway, when we do our perpendicular type feature. So, it would be marginally more accurate just because you've touched more points, but it wouldn't really change the calculation much. All right, so we have a line on the front, and then we'll come over and touch a point on the back. Now, does anybody remember anything we should look out for when we're touching this angled slot? Remember from previous labs? Some people had their probe was... Yeah, you could have an inverted normal vector. So I got around that by taking the points using the teach-in method. So that'll get around that. But another thing I saw is that the retract value was set so that it was wider than the slot. In other words, the probe was coming down on top of the slot like this. Right? It just was the default retract value in the software was a little higher than it needed to be. Sorry for giving you motion sickness here. I don't know if you can really see that. But basically, if the probe comes in too far over to one side, it's offsetting itself from the slot, and it's going to hit the model on its way down. So 2 things we want to watch out for there. Number 1, the clearance plane that it's using for those features. We want to make sure that's plus z. And number 2, we want to make sure that the retract value for those features is set small enough so that the probe can actually fit inside of the slot. A retract value of 50 thousandths is usually pretty good. 100 thousandths would work well in many applications too. I believe the default is set to a 1/4 inch. That's just a little too big.
Use that retract value of 1/4 inch on the base alignment.
You use the retract value of a 1/4 inch on the base alignment features only, so that's that first plane, line, and point. After that, I would go with anywhere between 50 and 100 thousandths on everything else. Smaller values when you have tighter features. If you make the value too small and the part deviates, you'll actually crash into the part. So I wouldn't go any smaller than 50. All right. So do we have what we need for balloon 11? Yes. And how about balloon 12? What do we need there?
3D line.
We need a constructed feature. Very good. So we have this circle here, we have that circle there, but we don't have any feature that connects the two of them. So we'll come into construction, or I'm sorry, we'll go features, 3D line. And it's actually, I'm sorry, I misspoke. I said constructed feature. It's really a recall in this software. So we're going to hit option. We're going to hit the options pull down. We're going to come to recall. And we are going to grab circle 4, is it? And circle, I don't even know what the other one is. Circle 4 and circle 1. Now the order you select these in is important. You want to click on number 4 and then hold control and then click on number 1. And if that angle comes in backwards, you want to reverse that. You want to select on circle 1 first and then circle 4.
You can't toggle it to positive, right?
It's not easy.
Yeah, you just reverse it. So
Yeah, it's
4 to
easy.
1 or 1 to 4.
It's easier to reverse the recall selection. Yep. So in this case, we're actually at our last balloon anyway. So we're going to do the balloons systematically, but because we're here, see how that's 45 degrees? And notice that it's actually pulled off of a center mark. So we can take advantage of the Cartesian coordinate system here because the center mark is implied to be square to your primary datums. And we're pulling our angle here off of our primary datums. So the reason we don't have to create another line that is vertical is we're taking advantage of the alignment that we already have. Right? So we want to be somewhere close to 45 degrees. And notice that with our A1 right here, we have 45 degrees. So I'm actually outputting a direct characteristic here. All right, so that created 3D line 1. Now we'll come over to characteristics, and here's our projection angle. And we want to name this B12 underscore 45 PG, or 45 degrees. And let's see. We could mention the two features that it goes between. This would be 1 inch 181 and 472. All right, our nominal value should be 45 degrees. And what's our plus or minus?
5.
0.5.
0.5, plus or minus half a degree. We have to look in the title block. Now I know this seems like I'm splitting hairs here. These machines literally split hairs. Like, you can split a hair 40 times easily. You have to split hairs when you're creating these dimension reports because that's the difference between a good part and a bad part. All right, so you really have to pay attention to detail here. The upper tolerance is 0.5, the lower tolerance is 0. I will say okay. Now as of right now,
Negative 0.5?
yeah, you're right. Sorry, plus or minus 0.5. You are correct. Yeah, I was thinking angularity. Angularity, you can only go positive. So thank you for that. Notice that this comes in as gray. Why is that coming in as gray? Yeah, when we look on our features tab, circle 1 hasn't been measured yet. And you know what? This is actually a good time for us to go measure the features. But while we're at it, I think we can use the final exam instructions as a guide here. So CAD, import and position the part in 15 minutes or less, done. CMM, logical probe selection based on features to be measured. Now I didn't explicitly talk about this, but all of the features that we measured were big enough to fit this 3 by 50 millimeter probe in there. If we were measuring something really small, like this right here. If we were measuring those through holes at the bottom of these counter bores, this probe simply would not fit in there. We would have to switch over to the 1.5 by 31 millimeter probe back there. So this one's kind of a gimme. If I'm remembering correctly, on the other version of this final exam, you can use the 3 by 50 millimeter probe through the whole thing as well. Right, a probe selection that would not make sense if you tried to use this stylus of a star probe to inspect this part. It's just not going to work. It's not pointing the right direction. So, logical probe selection. We are good to go there. All right, measurement. Base alignment matches blueprint. We talked about that already. We made sure that datum A was our plane, datum B was our line, and datum C was our point. That alignment will be different on your final exam. Pay attention to that. If you get the alignment wrong, everything else is wrong, unfortunately. There'd be a huge amount of points up. And that one's a gimme. Clearance plane is set between 100 thousandths and 1 inch offset from the CAD model. In other words, your clearance plane is not, it doesn't want to be 2 inches above the part here, but it also doesn't want to be, 20 thousandths above the part where you're dragging on it. So 100 thousandths to 1 inch above is fine. The default, if you use clearance plane from CAD model, is within those values, 300 thousandths or so. Characteristics, all balloons output. All characteristics use STCC naming convention. Dimension report is in order of balloons. All nominals, high limit, low limit are correct. Okay, well, we're actually not there yet. Features. All features are measured. No collisions. Path efficient. Edit strategies as necessary to take appropriate number of points based on feature type and tolerance. That's a mouthful. Basically what that's saying is this is plus or minus 2. We took 7 points instead of 4. This was a slot where we needed to have a line on one side and a point on the other. We made that accommodation. So it's talking about things like that. Okay, but we don't yet know if there are collisions or if it's path efficient. And also, as far as running our simulation goes, I do, even when you're taking the final, I do want you to call me over so that I can verify that your programs will run without crashing before you run them. This is kind of a moot point if you're using the teach-in method because you'll have driven to all the points and it shouldn't crash. But one way or another, I'm responsible for making sure that these machines don't get damaged. So at this point, I'm ready to run my features. I would call the instructor over and I would go to, first I'll turn my speed dial all the way down on the controller. All right, so I turn the speed dial all the way down. And then I'll come over to CMM settings. I'll turn on simulation only. And this is important. You do have to hit connect to ironically disconnect from the machine in this case. It's going to think for a second. The stylus system will turn red. When the stylus system turns green again, that means it's ready to go. Now we'll go planner, measurement plan simulation. Notice that the part has been positioned on the machine in the correct spot. How did it know where to put that part? I already did the manual alignment. When I did the manual alignment and took the points off of the part itself, it placed it within the machine's volume in the correct location. So that's the beauty about being able to do this right on the machine. It's like you don't even have to position the CAD model. In fact, you do not want to position the CAD model. Your manual alignment will position it.
So only orient it, but don't position it.
Only orient it if you have to. Yep, so all you'll have to do is spin it one way or another. Right? You'll either rotate about X, about Y, about Z, or some combination, but you'll do no linear movements at all. That is an important point. I would put that in your notes. Yeah, and I put a star next to that as well because you're probably so used to positioning it from doing this offline that it'll be a little different.
We haven't even been required to position it.
You have not been
yet
required to
until
position
the
it.
last months.
Yeah, you haven't been required to position it, but and that is something that I wish I mentioned that earlier in the semester to all of you, but we never had the opportunity to do offline programming on the machine. But that's a big deal. Don't try to position it on the real machine. If you were writing this program offline on a computer, go ahead and position it. That's fine, because when you bring it over here, you'll do the manual alignment and it will correct it. But what you don't want to do is position it on the machine, because the machine will drive into itself. You don't want to override your manual alignment with some random CAD position.
Could we do the final on a computer and then bring it over?
You are also welcome to do your final on a computer and then bring it over to a machine. That's completely fine with me. Yep, as long as it's all time constrained. You just have 2.5 hours to complete it. Yep. All right, so I digress. Let's. So I have my measurement plan simulation open here. Collision detection is on here. Speed dial is all the way down, +1. I'm going to come over to the Features tab, do Control A to grab all, or click on the top one, hold Shift, click on the bottom one, whatever your favorite is. We are going to clear existing results. We want the named alignment. We want to do current selection from feature list, clearance plane, slow through first feature, and 55. Make sure your speed dial's all the way down and hit start. All right, and now we're just, so at this point, you should probably check this out once at least before the instructor comes over, just so if you see any errors, you can correct them. And as soon as it looks good to you, you'll call the instructor over. Now, I already noticed some problems here. Did anybody else notice some problems? We missed the step.
I was going to say we didn't check if their clearances are all in +Z.
Yes, very good. We did not check our clearances. I'm noticing another problem here where this program is not path efficient and the clearance plane for that last feature was -X. That one was -Y. And the retract for that one is going to potentially crash into the back wall. So I found all that out from the simulation. That's the level of detail you should be paying attention to. So let's go fix those things. We'll be in Measurement tab.
Before you do anything though, shouldn't you just go into what you just did there and just check that before you even run? Before you can do any of that, right? Run a simulation.
Yeah, oh yeah. Do a simulation, and that's what told me I forgot
That's
all
what I
this.
did. I checked that. And
Yeah.
Set off.
Yeah, it's a good idea to do a simulation.
Before
You'll
you
probably
run it, so you save.
you'll probably find all sorts of issues. Yep. So we have +Z, -X, -Y for our clearance plane. We'll go to Travel Clearance Group. We'll highlight everything, and we'll go CP +Z. All right, so that's number one. Second thing is the clearance distance. So this clearance distance is blue and it has stars. That's picking up the default off the system. If the default on the system isn't 0, this will just pick it up, whatever it is. Even if it's a 1/4 inch, that can cause problems. So we want to make sure we set this to 0 and all the text turns black. That's good. Retract distance. For our first 3 features, that's set to a 1/4 inch. Notice the blue stars. That's all the default from the system. And the default on this system is a 1/4 inch. That's why a lot of you ran into problems here, but you didn't run into problems on your own computers. Because if you leave those as blue, it's picking up the default of whatever computer you're sitting at. So we want to see all of these as black. That means for this file, it's going to be this value no matter where I'm sitting, no matter what the defaults on the computer are. So for circles, or for every feature from number 3 onward, we're going to set those to 50 thousandths, and notice again that the text is now black, not blue. All right, so that was a big one. We corrected our clearance. We corrected our retract. What else did we have to do?
Arc motion. Shut it off.
We could do arc motion mode and just turn that off.
I was going to say, if you did the one like from a computer and imported it, you wanted to make sure that the probe is set to...
Yeah. If you created this on a computer and the name of your probe is not an exact character match, you would want to hit the pull down here and go to Stylus System, and you would want to grab everything and make sure that that is the 3 by 50 millimeter stylus. All right.
I thought you said you would run into a problem by setting the clearance distance to 0.
Clearance
in
distance?
In a real world situation.
No, so clearance distance, if you set retract to 0, that would create a problem. The clearance distance isn't what it sounds like. Clearance distance is for if you have an inclined plane. Like let's say we had a plane on this surface here. Or let's say we had a hole on this surface here. the way that the probe would get in there is, first of all, you'd have to have a probe that's at an angle, right? Otherwise, when you came down, you'd hit the shank before you hit the ruby. So the probe would be at an angle. But when it approaches, it can only approach from the standard 5 faces, meaning plus z, plus x, plus y, whatever it is. Well, as it gets into the feature, it has no way of touching 4 points on the diameter without penetrating into the feature. And the direction that it goes to get into the feature is called clearance distance. So the clearance distance is normal to the feature that you're measuring. And it actually gets added to a lot of other things. So in this case, the clearance distance, if applied to this slot, would first, if we touch that as a line, the normal vector or the normal retract of the line would be that way. It would add the clearance distance plus the retract, and then it would go to our clearance plane. So clearance distance isn't what it really sounds like, and it almost never applies unless you have inclined features. Always wants to be 0 unless you have an inclined feature. So I think there may have been a video where I got that twisted and misspoke, but what I just said here is 100% sure. All right, so long story short, for this software, clearance distance is weird. It's not what you think it is, and it almost never applies, only on inclined planes. All right, so it's interesting now because all of my features appear to be green. I only have data from the CAD model. I do not have a point cloud from the real part here. I've overwritten any points that I've taken off the real part with the points that I took off the CAD model. So that's important to recognize. It's going to make the part look good when it's not necessarily good. Another thing I noticed as we were running this is these features were not path efficient. So under features, notice that path efficient is one of the things that I'm grading you on. If we want to make this more path efficient, should we really do circle 1, circle 2, circle 3, circle 4, and then point 1, point 2, or point 2, 3, and 4? Now we should do circle 1, then point 2. And we should do circle 2, then point 3, then circle 3, then point 4. So now we're going circle and the depth of the circle. Circle and the depth of the circle.
I was tempted to put that in like a group.
It is tempting to put those in a group, and that would probably be good if you did that. Yeah. Yeah, you could grab all 3 of these and right-click and go Form Group, and then you could grab your alignment features and Form Group, and you could rename a group Align, and you could rename that 3 times Circle, or whatever you wanted to name it. That would be a good idea. Now we have circle 4. We have 2D line 2 is on the left part, so that's reasonably path efficient. Then we do that line, then we do a point on the front. We do a line on that slot, a point across from it, and then that is not actually a measured feature, it's a constructed feature. So that is reasonably path efficient. It's just, it's just saying you don't want to be measuring something here, then there, then back to here, then back to there, then back to here, then back to there. Group features based on their location, if you can. All right, so now that we've corrected all of our measurement plan editor features settings, and we have reorganized our features menu so that it's in order, let's grab all of that. We'll slow our speed dial all the way down on our controller. All our settings are already set. We're clearing existing results. We have our named alignment, that's the 3rd one down selected. We're doing current selection, features list, clearance plane, slow through first feature, and 55. Notice that we're hugging the part much tighter than we were before, in between features, or in between individual points on features. Some of you might be noticing that we have an unnecessary retract in between touching the diameter of the circles and the depths. You don't have to fix that. I'm not going to take off points for that, but does anybody know how that would be fixed? You could do a subclearance plane. Yeah, and if you had a lot of concentric circles, you could save a lot of time. Quick little sidebar here, if you wanted to see how to do that, you could grab circle 1 and point 1. You could come over to the measurement tab, measurement plan feature editors, so they're already selected here. We could go into travel clearance group, and we could set this to SCP plus Z. You could grab 2 and 3. You could do SCP 2 plus Z, for the third one, we could do SCP-3 plus Z. So just for ha-has, if we ran all three of those again, let's see the effect. See how it doesn't lift unnecessarily? Oh, it's a beautiful thing. But you don't want to waste, 10 minutes programming to save 30 seconds running a part if you're only inspecting one part. But if you're doing 1,000 of these things, yeah, that is some significant time savings there. So it's worth doing that. That's like icing on the cake if you want to do that in your final. That just really says you've been paying attention to the lectures. All right, so that looks good. Now let's move on to characteristics.